Let's move to our next topic, which is method overloading. As I told you in my previous class, that method overloading is a way to achieve compile time polymorphism. How it is achieving compile time polymorphism, I'm going to explain it later. But before that, we will first try to understand what is method overloading and how many ways we can implement method overloading. If you define more than one methods in the same class but with different parameters, then that is known as method overloading. You can change the parameters by three ways. Either you can change the number of parameters, or you can change the data type of parameters, or you can change the sequence of parameters. Let's see their implementations. So the first way to implement method overloading is by changing number of parameters. Here I have defined a class with the name of method overloading 1, and I am having display methods with different number of parameters. For first display method I have one parameters, for second one I have two parameters, and I am even printing the parameter value. Okay, and for third display method I am having three parameters. Then I am instantiating method overloading class, and then I am calling all these three methods one by one. Okay, if I run this, you will see all these three methods are executing one by one. So this is the first way to achieve method overloading by changing number of parameters. The second way to change the parameters, as I told you, is by changing data type of parameters. This implementation is of method overloading by changing data type of parameters. As you can see, first method is having int type of parameters, and second method is having double type of parameters, and third is having further other type of parameters. And whatever the parameters type I am passing here, the same type of method is getting called. Okay, and you can see here I am passing float type of value. I already taught you this in data types classification, that floating point literals by default treat as double in Java. That means these two values are by default of double type, and that's why the second method is going to be execute. So let me run this. As you can see, all three methods are getting execute one by one. This is our second way of implementing method overloading, which is by changing data type of parameters. The third way of achieving method overloading is by changing sequence of parameters. How we can implement this? Let's try to do this. I have this first method, and then I am creating one more method which is again having parameters, but I am changing their sequences. So for first of the method, the sequence is int double type for the arguments, and for second method argument became double and int type, means I am changing the sequence, the order of formal arguments. And if I am doing so, and when I'm making the call here, if I am passing double parameter as first parameter and second parameter is of int type, which means this method is going to execute. And when I pass int first and I'm passing double as a second argument, then this method is getting execute. And this is our third type of method overloading, which is by changing sequence of parameters. Now, technically speaking, this third type is nothing. Here also we are actually changing the data type ultimately. For first method, parameters are int and double, and for second method, the parameters getting changed to double and int. So it looks like we are changing the sequence, but ultimately we are changing the data type only. So we can say that method overloading is achieved by changing parameters mainly by two ways. One is by changing number of parameters, and second is by changing data type of parameters. But some books write like this, that we have three ways, and that they mention the third way is by changing sequence of parameters, which I also explained you. Now let's try to understand how method overloading is achieving compile time polymorphism. In compile time polymorphism class, I explained you that compile time polymorphism is nothing but when object bound with the functionality at compile time is known as compile time polymorphism, or is also known as static binding, or it is also known as early binding. So you can see I am creating an object and then I am calling a method, and this method calling is defined at compile time itself. This object is going to call this parameterized method only, right? And this binding is fixed. This is not going to be changed unlike that happens with dynamic binding or runtime polymorphism. Here the binding is fixed, the binding is at very early stage, and that's why it is known as static binding, or that is known as compile time binding, or that is known as early binding. Okay, so object bound with the functionality at compile time is known as compile time polymorphism, and method overloading is a way to achieve compile time polymorphism.